Let's take a few minutes and discuss some advanced topics surrounding Windows Azure roles. When Azure was first released, web roles did not have the ability to take advantage of all of IIS. With a recent service update, web roles have been updated to use full IIS in Windows Azure. You also now have full admin access to your role instances, and for network modeling, you now have the ability to use well-known ports, allowing you to bring your existing applications into Azure much easier. You can also specify port ranges for inbound traffic. You can also add and remove instances from the load balancer, for example, if you want to debug a specific instance. And you now have the ability to enable traffic filters between roles within a service. Recent updates have also provided improved automation, including startup tasks that you can use to prep and configure your roles, and role plugins, which provide diagnostic or remote desktop capabilities. Digging a little deeper into the admin access and startup tasks, some of the scenarios where you might use startup tasks include the need to register a COM component, read a registry key, or configure a Windows Server role. This is a good place to do some debugging functions as well, such as turning on trace logs. However, keep in mind that your runtime state on an operating system image is not durable, meaning that it will not survive an operating system failure or a hardware failure. Yet, your service should behave correctly even though a role instance may fail. So let's take a deeper look at the task types, as there are 3 task types. There's the simple task type, which is the default, which will wait for the task to exit before another task is launched. There's the background task type, where the system does not wait for any task to exit. And then you have the background task, which is similar to a background task, except the role is not restarted until all foreground tasks exit. Let's take a look at how this is configured in the service configuration file. In the task element, you first specify the command line, which is the path to the executable. You then have the execution context, which specifies whether the task will run with limited or elevated privileges. And then you have the task type, which specifies whether the task will run as a simple, foreground, or background type. Now, obviously, for the execution context and the task type, you have to pick one of the available options. You can't combine them. There have been several versions of the Windows Azure SDK, the latest being version 1.4. However, since version 1.3, you have the ability to use remote desktop services to access Windows Azure roles. For roles that have input endpoints, that is, roles that are accessible to the public, the only thing that is required is the remote access module. However, for roles that do not have an input endpoint, you will need to have an internal endpoint on port 3389 that is accessible through the role with the input endpoint. For example, in this image, there are 2 roles, role 1 and role 2. In order to remote desktop into role 1, only the remote access module is sufficient. However, if we want to remote desktop into role 2, we need both the remote access module and the remote forwarder plugin on role 1. So you might be asking, what are the remote access and remote forwarder modules? These are actually nodes in the service configuration and service definition files, and they only appear when we publish our application to Windows Azure via Visual Studio and select the Configure Remote Desktop Connections option in the deployment dialog. When we enable remote access, the service configuration file contains the username and password necessary to remote into the instance. This information comes from the information that is entered on the remote desktop configuration dialog that is displayed when we selected the Configure Remote Desktop Connections option on the deployment dialog. So let's discuss local storage for roles for a minute. Each role can define an amount of local storage resources, including protected space on the drive. Again, this role is volatile, meaning in the case of a hardware failure or operating system crash, any data is lost. Each storage resource can be defined with different sizes, ranging from 1 megabyte to over 20 gigabytes, and you can set these resources up quite easily by defining them in the configuration file. Here's an example of creating a local storage by using the local storage element in the service configuration file and specifying a name, a size, and also the clean on roll recycle parameter, which specifies whether the local storage resource should be wiped clean when a role instance is recycled or whether it should be persisted across the role lifecycle. The default value for this option is true. The Windows Azure Managed Library provides classes for accessing the local storage resource from within the code that is running in a role instance, including the getLocalResource method, which returns a reference to a named local resource object. Because the local resource object represents a directory, you can read from it and write to it by using the standard .NET File I/O classes. In this example, we are specifying a file to upload, and once uploaded, opening that file for reading. The great thing about Local Azure Storage Emulator is that you can simulate running in the cloud, and that also includes resources and files. When working and debugging locally, files are stored in your user directory and paths that are really just too long to type, let alone find. But if you really want to go hunting, here are some examples. So let's talk endpoints for a minute. Roles have endpoints. You have input endpoints, which we have just talked about. And these input endpoints expose a WCF service to the public. And these endpoints are also enrolled in the Azure Load Balancer. The Azure Load Balancer is aware of these endpoints and will make them available and load balance those across the multiple instances. You also have internal endpoints. These endpoints are not exposed to the public, yet they are exposed as endpoints to other internal instances. They are not enrolled in the Azure Load Balancer, and they are usually used in a peer-to-peer-like manner. The great thing is that you get up to 5 total endpoints per role, which can be defined, either HTTP, HTTPS, or TCP. So let's take a look at the endpoint model. You have requests coming in through the load balancer, which are talking to input endpoints. So I have worker role instance 0, instance 1, and instance 2, and these are my input endpoints. And these are also talking to internal endpoints, worker role 1, instance 0, 1, and 2. Configuring an endpoint is actually quite easy. The port defined on the input endpoint is what is exposed at the load balancer, but is also what is used at each instance. This is known as a well-known port. Notice that you don't set a port number on the internal endpoint, and this is because it is assigned when the instance is deployed. You can get access to the endpoints at runtime. Once configured, these input endpoints show up in the configuration file as shown here. Now, if you know anything about WCF, you're in great company because endpoints and accessing endpoints are just like accessing and using WCF services. It is just like a normal WCF service. All you need to do is define your address at runtime and select from the instance endpoint collection. And the typical pattern is to loop on all internal endpoints. Let's talk about Windows Azure Connect for a minute. Windows Azure Connect is all about securing your network connectivity between on-premise and cloud. The great thing is about Windows Azure Connect is that it supports your standard IP protocols. So the question would be, when would you use the Windows Azure Connect? And there are several use cases. One example would be is if you have an enterprise app that is migrated to Windows Azure that requires access to an on-premise SQL Server, you certainly want to secure that traffic. Another example would be if you have a Windows Azure app domain joined to a corporate Active Directory domain. And the last example might be if you are doing remote administration and troubleshooting of a Windows Azure role. The great thing about this is that it is simple to set up and maintain. All this is done through the Windows Azure Management Portal. Taking a closer look at Windows Azure Connect, Windows Azure Connect is enabled for external connectivity via the service model. Windows Azure Connect enables local computer connectivity by installing the Windows Azure Connect agent. Most, if not all, companies have a network policy, and the Windows Azure Connect network policy is managed by the Windows Azure portal to provide a more granular control over connectivity. Windows Azure Connect also provides automatic setup of secure IP-level network between role instances and local computer via tunnel firewalls and NATs through a hosted relay service. This is secured via an end-to-end IPsec with DNS name resolution. Now, with all this talk about Windows Azure Connect, we do need to let you know that it is in CTP right now. The CTP is available with the on-premise agent for non-Windows Azure resources. This supports Windows Server 2008 R2, Windows Server 2008, Windows 7, Windows Vista SP1 and up. And you can sign up on Windows Azure Portal under the beta programs. For future releases, Windows Azure Connect will enable connectivity using existing on-premise VPN devices. All right, with that, let's do a demo. So in this example, we are going to create a simple web role that is configured to allow remote desktop connections. So to begin, let's fire up a new instance of Visual Studio. And let's create a new project, and we're going to create a cloud project. And we're going to call this project Hello. Well, actually, we'll call this Hello World RDP, because we're going to remote desktop into the instance. So click OK. We want to create a ASP.web role, and we're just going to rename this Hello World. And click OK. All right, we're really not going to do much to this. We're simply going to modify the default page. So let's add a new line. Let's drop a label. Drop a label on there. Let's look at the properties of that. Let's set that label to font to extra large. Now let's go in here to the view the code behind that. On the page load, we want to say label1 dot text equals hello Windows Azure. All right, this isn't critical to the RDP, but it just gives us something to look at when we load the page. Great. We're done with that. Now comes the important part. Let's compile that just to make sure that everything's working correctly. Wonderful. But here's the key. Let's right mouse click on our Windows Azure project, and let's go to Publish. We don't want to deploy using our Windows Azure project. We do want to deploy, though, by creating the service package only. But the important part is here. Let's go down and click the Configure Remote Desktop Connections. And we need to enable the connections for all roles. So we're going to click OK. The key here is the certificate. So if I have already created a certificate, if you haven't already created one, you can click Create and simply enter a name. But I've already created one. And let's enter a name. We'll call this Scott. We'll enter a password. And there's our expiration date. It's a month from today. Now, before we click OK, what we need to do is we need to view and export that certificate. So go ahead and click on the View button, which brings up the certificate dialog. And on this dialog, we need to click the Details tab and scroll down until we find our certificate that we created. And let's copy that to a file. So let's click Next. And here's where it gets a little tricky. We do need to export the private key, so click Yes, Export the private key, because this will export the private key as a .pfx. That's what we need to do. We're going to click Next. We're going to give it a password. I'm just going to use the same password I entered before. We'll click Next. Export to a directory. Let's replace this one that we created before. We're going to click Save. Yep, let's replace it. Click Next. Click Finish to export it. Yep, the export was successful. Click OK on this dialog, and then we can click OK on a remote desktop configuration dialog. And then we can click OK here. Wonderful. This is the dialog that we need, showing us the directory where our service package file is and our configuration file is. So we're done with Visual Studio, so let's minimize Visual Studio. And now what we need to do is we need to go into our Windows Azure Platform portal. And what we want to do here is we want to go into our hosted services. We have no hosted services right now, so what we need to do is we need to create a new hosted service. So let's click on that. And we're going to enter a name, so let's call this app dev RDP demo. we'll call this the same thing, app dev RDP demo. Wonderful. So that's that URL is available. Let's choose our North Central US. We are going to deploy to the production environment. We want to call this version 1. And let's browse to our package configuration file. Now, there's a trick to this. You can actually go back up to your Windows Explorer dialog and copy the URL, paste that in here, and there's that. And we'll do the same thing for the configuration file. Paste. There's our configuration file. Now, before we click OK, we need to add that certificate that we created. So let's add that certificate. We're going to browse to the one that we just created, and we're going to enter the password that we used when we created the certificate. And click OK. We're all done. Now we should just be able to click OK. So let's click OK, and what it'll do is it'll start uploading. Oh, we did get a warning. This is not an error. This is a warning that basically tells us that if we look at the details of this, simply says that we're deploying this with only one instance of the role. Do you want to keep going? Well, yes, I do. So let's click OK. Oh, we got to close this. Let's click OK. It's going to give us that again, but let's click yes this time, and now it's deploying. So this will take several minutes. So let's come back when this is done, and we'll keep going. So it looks like everything is deployed correctly, but we're not quite done. Even though we've published the app, and we've published it with RDP enabled, we still have a couple steps to do. So if we look at, let's test our deployment first and make sure everything works. So let's go ahead and click this link and make sure that we can get to the app. Here we go. So everything's working correctly. So the next step is we need to go over to the remote access section up here. But we want to do that on the instance level. So we clicked on the role first to make sure that it is enabled. We can configure it from here. But what we want to do is we want to click on the instance level so we can click connect. Now we're not really going to connect from here. But if we click connect, it's actually going to download a .rdp file. So let's save that. And let's save it to our desktop. So let's go up here and let's select desktop. And let's just keep the name, and let's click Save. So the download complete. Let's click Close. We'll minimize our browser. We'll minimize our Windows Explorer dialog. Here's our RDP file, and we're essentially at this point done, but let's test it. We just simply double-click the RDP file, and we'll click Connect. And you'll notice that it kept the credentials that we entered earlier, and all we need to do is specify the password that we used, and we just click OK. And at this point, it's actually making a connection to our web role instance. Now we are going to get this prompt asking us that, hey, is this certificate trusted? Let's go ahead and click yes on this dialog. And there we go. We've now just RDP'd into our box. Or we've actually just RDP'd into our web role instance. Let's look around a little bit. Let's go into computer, and you'll see that we have a C, D, and E drive. Now we talked about this in the slide deck about the resources that we have available to us. So there you go. You have successfully just RDP'd into a web role instance. Let's leave this and we'll log off. And we're done. With this RDP file, we can continue to RDP into this box if we need to. But congratulations is in order. You've just successfully deployed a web role configured for remote access and successfully remoted into that web role instance.